Yes, hi, this is George Lerakis again, and today I would like to solve a problem in Riemann sums. This problem here, to my opinion, is exceptional. So what is the problem? The problem is like that in a specific factory, you have an equipment which by the time efficiency of this equipment it goes down, so that means that this equipment is just to reduce the pollutants that they go out of this factory. So as let's say the efficiency of the equipment goes down, more and more pollutants will be going out of the factory. And this table here gives us the time in months and the rate in tons per month that we measure at the beginning of each month. So as you see here, when we just start at 0 months, we have 6 tons per month. At 1 we have at the beginning of the first month we have 8. At the second 13. At the third 24, 29, 5, 40, 6, 54. And again, we said that the time is in months and the rate of emissions or pollutants is in tons per month. We're trying to find how often we should measure the pollutants in order the difference between the overestimate and the underestimate to be exactly 1 ton. So first of all, we do the graph, of this table here, which is this blue line that you see here. Of course, here are the values in the values of time in months, and here are the values of the rate, which is in tons per month. Here, if someone wants to find an underestimate and overestimate, you have to go with left endpoints and right endpoints. And actually, this is because if you see this graph here is increasing. So actually, the overestimated will be taken by the right endpoints. For the visualization of the problem, I just take 6, let's say the delta x or the delta t will be 1. So that means I will have 6 such rectangles. And as you see here, the ones that are, with a red line are the left hand rectangles, and the one with the green are the right end point rectangles. Let's say, so that means that for this, just to show you, I take the R6 and the L6, capital R6, capital R6 and capital L6, which means that these lower R1, R2, R3, R4, R6 will be the the rectangles that we were talking about before, the green ones, and the L1, L2, L3, L4, L5, L6 will be the red ones, which are actually the ones for the underestimate. So if you see here, if you take, let's say, the R6, if you take the R6, that will include, all these, let's say, green rectangles. Okay, the R1, R2, R3, R5, R4, R5, R6, and if you take the L6, that will include the smaller rectangles, which is L1, L2, L3, L4, L5, and L6. So what you have to do is you have to subtract them in order you have to subtract them in order to try to create, this Rn minus Ln that we're trying to create in order to find the n for which this difference here it will be equal with exactly 1 ton. So if you see here, you see that, let's say if you start from the R6, so you have the, this big rectangle, and then you have this R5 rectangle. So, but you see that this R5 is actually equal with the L6 of this here, of the left hand point. So you see that this here will cancel this here, and then if you take the R4 for the capital R6, that will cancel with the L5, R3 with L4, R2 with L3, and R1 with L2. So you see that the only ones that they will remain when you take this difference here, it will be this. So if you take the R6 minus the L6, so that will be equal with R6, lower R6, minus L1. Just, I want to explain this again, because that's the most critical point here, is that when you try to create this difference here, R6 minus L6, which is the right-hand point rectangles, or Riemann sum, minus the left-hand point Riemann sum. So when you try to take this difference, you see that when you start taking the only thing that, starting from R6, then you go to R5. So the R5, it will be exactly equal with the L6, which is here. So this cancels with this. So the R4 will be equal with the L5. So the R4, which is let's say the fourth rectangle with for the R6, it will be cancelled with the L5 of the capital L6 and so forth. So the only things that will remain, it will be the rectangle R6 and the rectangle L1. So the one R6 is from the right hand Riemann sum, and the L1 it will be from the left side Riemann sum. So, why I did all this? Because I just want to show you that doesn't matter how much this will be, or this. The main point is that the only thing that it will remain from this difference, it will be the last rectangle of the right hand point Riemann sum, and the first rectangle of the left hand point Riemann sum. So, and now, since we are trying to find this n here, so let's assume that you split this in this interval here from 0 to 6, you split this in n points, okay? So let's say, this here, this small thing, it will be equal with what? It will be equal, if we have n intervals like this, how much it will be each one of them? Of course, it will be equal with this distance, which is 6 over n. So that means, to come again to this point here, that the last, let's say the Rn, it will be equal with how much? it will be equal, because of course this here is a rectangle, so that means that the area of this rectangle, it will be length times width. So the length, of course, it will be equal with all of these, which is what? It's 54. And the width, it will be, we said, this here, which is 6 over L. So that's the Rn, and the L1, it will be how much again? Like let's say this here, it will be the L1, this rectangle here. So it will be again, since it's a rectangle, the area of the rectangle, it's length times width. So the length, it will be this here, which is what? Which is 6 times again, this interval here, which of course again, it's equal with 6 over n. So so that's the equation that we have here. So if you take now 6 over n as a common factor, what do you have inside? You have inside 54 minus 6, which is of course 48. So that means that we need this here to be equal with exactly 1 ton. So it's this equation here. So of course, if here you solve for n, you find that n is equal with 6 times 48. And since we have 6 months, so that means that we have to take measurements 48 times per month in order the difference of the overestimate over the underestimate to be exactly equal with 1 ton. So again, the question here, it was how many times per month we have to take measurements for the pollutants. And since we find that the n is equal with 6 times 48, so we have 6 months, so that means that we have to take 48 measurements per month in order to have the outcome that we want, which is the difference between, again, the overestimate and the underestimate to be equal exactly with 1 ton. So again, this is the problem which, to my opinion, I find to be an interesting one. Thank you for taking the time to view this video, and I hope you find it useful, and bye for now.